every participants. Myself, Professor Yagnesh Jamba. I welcome you to all on day 5 STTP on automobile engineering beginning of new era.
The times are changing. With more than 10 lakh students. Come. Times are changing.
So we are proceed to start the sessions. I request to all the participants kindly mute your mic as well as camera. So I would like to hello, am I audible, Nikunj sir?
Yes, please.
I would like to invite Professor Nikunj Yagnik from Automobile Engineering Department to introduce the our today's speaker, Mr. Aditya Shukla. Please, sir.
Thank you, Yanis. Hello, good
Yes,
afternoon.
yes.
First of all, I would like to thank all participants for attending this Guj Coast sponsor STTP on automobile engineering, beginning of new era. If you see the beginning of new era, people can talk on hybrid vehicle, people can talk on electric vehicle, people can talk on autonomous vehicle or connected vehicle, and we have so many lectures on or session on this kind of electric vehicle or advanced drive line or advanced featuring tractor technology also. But if we see, there is a need that we need to produce the component which are from manufacturing system. We need to improve in that regard also. So by considering that the era that is not only connected vehicle or autonomous vehicle, the element which are being utilized or developed or manufactured, for that there are various systems are there, and we need to improve that system in such a way that the consumption of energy will be as low as possible. If you see in paint technology also, there are low temperature heat source are there, or many OEMs, they are utilizing many other technology. They are improving that quality by continuously improving their production process and driving towards low carbon emission, enhance sustainability also. So there is a need that we need to focus on manufacturing system also. So based on that, today with us, we have one of the award-winning professional, Mr. Aditya Shukla, working in Tata Motors Sanand, and he will be delivering on technical session on automotive OEMs, manufacturing system, driving quality to efficiency. He is one of our brightest student, currently alumni of ADIT, and Thanks, Aditya, for accepting this invitation and coming to deliver this technical session. If I would like to share this bioscope or biosketch, Aditya is currently working as a senior manager Tata Motors at Sanand unit. He has done his bachelor degree from ADIT college in 2012. He got awarded in Baha competition in marketing, the best marketing presentation ever. He initially joined General Motor and worked there for almost 6-7 years, both in Halol unit as well as in Pune. He worked in quality assurance department as a deputy manager. Then after he joined Tata Motors Sanand as a senior manager. Now, not taking too much time, I request Mr. Aditya Shukla to take over this session, this technical session. Thanks again, Aditya. Please start your presentation.
Thank you, sir. Thanks a lot. Thanks a lot to everyone over here, all the participants, for coming to this session. And I sincerely hope that you're going to get a good insight of the whole automotive systems, the main automotive systems, or the base of all things that we do as an OEM, and the things that you're going to learn in this during this session is really going to help you all, and maybe our next batch of students who are going to get these things from you or not in this session, and all the faculties, all the esteemed faculties who are with me today. So before I start off the session, let me give a brief of myself. So as Sir said, Yagni Sir said, I passed out in the year 2012. So I was just going through that video that Yagni Sir just played. Felt a little bit emotional connect, because we for 4 years we had a good connect with the college. We had some good faculties. We had our fun. We had our learnings. So with all those things, we passed out of the college. So in the year 2012, I joined General Motors at Halol facility. So there I worked with the quality department, and that my particular role was majorly into manufacturing systems, wherein we were involved in ensuring that all the shops are aligned to the systems that we have, that the company or the organization esteemed as such as GM had designed, and ensuring that all the products are made up to the standards. That is not only the last product, the end of line product that you as a customer see, but starting from the stamping shop to the body assembly lines to paint shop, then moving to general assembly, and then moving to yard. And before even the vehicle gets dispatched to dealer, we had one inspection stations. So we had all the checks, we had all the systems defined for the same. So not only that is a part of inspection, but we were also involved. Speaking of me, I was also involved in processes and ensuring the efficiency that is driven through processes. So that is something that I will be delivering today. So that was my journey for Halol, where I worked for around 3 years. Then I moved to Pune assembly plant, which is there at Talegaon location. So there I worked again at BAW manufacturing and quality level. Then working with quality systems, working with the global teams, ensuring that the systems that are being implemented and that are being escalated to next level are being coming to a plant, directing from the plant leadership to us, and making them sustainable enough that the efficiency is driven and we are getting a product that meets the expectation of the end customer, and closing the loop that came as a point of contact of reliability or maybe initial level failures. So there I worked for. So my journey with General Motors was around for 7 years. It has been more than a year that I joined Tata Motors. So here I am working as end of line senior manager, and my role here entails me to have a inspection and testing of the vehicles that are being rolled out of the line. We had systems, we have the share of systems that we got from General Motors, and the same, there are things that are being used in Tata Motors also. Maybe there are some changes in the names or the way we use them in our day-to-day life, but ultimately the systems remain the same. The foundation of each and every quality system remains the same, and the thing is that the things need to move in a sustainable and consistent way, so that the results that you are going to get are not only short term but also in long term. So I will be just presenting my viewpoints on those. We will have a great amount of examples going forward, because this type of sessions usually take 3 to 4 days, wherein we go through each and every point that are present as a system as a whole. So maybe this duration is short, but I will try to cover as much as possible. We will take this session for around 1 hour 15 minutes or so. Then we can have a question answer session. And if I don't have any time constraint as such, so we can extend if you want, and it depends on the type of questions or the quantity of questions that may come upon the end of this conversation.
Hello, Aditya.
Yes, sir.
Kindly switch on your camera. If
Okay, just a minute, sir. I think my presentation is visible to everyone.
just a minute.
Yeah.
Yes, yes.
Okay.
Requested to all participants in the Aditya Shukla presentation.
Okay. We'll start now. So this, while going to making this presentation, I just got a quote in between, and it was really to the really, you can say that it was something that was very core to this presentation, or the educational content that I'm going to take in next coming slides. So the quote says that success isn't always about greatness, it's about consistency. Consistent hard work leads to success, greatness will come. So I will be taking the case of my current organization where I'm working for. You can have a look at the portfolio of Tata Motors that was pre 2016. We had some good products like Nano, though it was performing as lackluster in market. We had products like Indica, which was a great success at one point of time. It was one of those vehicles that had achieved a level of 10 million, 1 million in about a duration of more than around 10 years, 12 years. We had some great products like Tata Sumo. So, but the thing that was not in the scheme of things for Tata Motors at that point of time was the quality. The people usually associated Tata's, if I take a look at Indica or Vista, it was majorly with taxi, and the quality was not something that was being perceived in market as something that you can associate with Tata Motors. Now, where I come from, an organization, I started my organization from a company like General Motors, where the ethos of working everything was quality, quality, and only quality. So post 2016, as one can see, we have Tata Motors had a product like Tiago, Tigor, then we came across Nexon, and today we have Harrier, Eltros. So these are the products that people consider as a quality product. That was not the case earlier in case of Tata Motors. Things have changed. Companies have taken a new look at the perceived quality, the question of reliability. So these are the things that require consistent efforts. So it's not a work of a day where you work for a day for making some good cars, and then the next day the things get to the again to the back words that the way we were going yesterday. So it's not about the hard work, it's about the consistency of doing the hard work. So the things that are going to come in the next slides are something that a company, in a case of Tata Motors or General Motors, they have a legacy of making cars. In case of General Motors, it's more than 100 years or so. In case of Tata Motors, it's not more than 30 years or so. So they have taken the things, they have taken the inputs from making those cars since a long duration of time, using them in making the new systems. So as a learned part of systems, whether where we are into launching of a new car, making the quality as a theme of ethos, in making of that particular prototype, moving to next generation of prototypes, and then to into mass production. So everything has some steps that needs to be followed, and if there is a problem in the system of steps that you're going to take, then we need to have checks in place that ensure that those steps are not bypassed, and the ultimate product that we're going to get is matching the product that was made earlier, or is matching the product that has been made in this organization for a longer duration of time. So it's not that the first car that is being rolled out of the line is not going to have quality because it's a new product. It's the first car that is being rolled out. It's not that. It's always a consistency in each and every model that needs to be taken care. And these particular systems and the efficiency parameters that are going to look at is going to drive those things for an OEM starting from the launch to the end of life cycle of a product. So how making good vehicles requires some consistent effort with systems leading them all the way to making them a brand associated with quality. So here on my screen, you can have a look at some of the global OEMs which have been associated for quality, other than, of course, quantity, and good vehicles that they've been known for. So the first one on the top right of your screen is Toyota. Again, it's this is the company basically which has been associated in making the reliable and quality products that are been benchmarked for majority of the OEMs since 1980s. So this is something Toyota is always associated with, and their logo and their way of thinking is always towards quality. Second, we are looking of General Motors, which at a particular point of time I was proudly working with them. Then we have VW, of course, Honda, Ford. So these are the companies that have a tendency of every time putting customer as a part of something they are doing on daily basis, on a consistent basis. Because if I ever look at today's customer, he's not going to spare any of those brands or any of the products just because it's in cheap in cost, or it's something that he's paying for. So it's not acceptable to have a product which is not designed, which is not made to the benchmark that has already been set from a different OEM or from a different supplier. So those are those very things that require consistent efforts, leading to what we have, which we call as durable and reliable product. And at the same point of time, we can have a different session of perceived quality, but perceived quality is something that has improved leaps and bounds. If I compare the case that was 10 years ago and to the point where we're sitting right at this point of time. So this is if I consider a case of a system of as a whole. So this is point of time. This is point of loop of improvement which we're talking of. So once a product is given a go ahead from marketing, from top management, it is moving. It moves to engineering department. From engineering, once they are been through with all the types of designing and all the types of validations, this the first type of first prototype comes to manufacturing line. So we will looking at manufacturing point of view over here. So engineering to manufacturing, we have a build process, build of materials that goes into making a particular product. Then into manufacturing, we have different types of being prototypes in each build stage. Suppose if a vehicle is being launched today, the the vehicle reaches to manufacturing lines maybe 1.5 years before. So from engineering to manufacturing, it takes around 12 months. Then it comes to manufacturing, where manufacturing takes around 1.5 years. Then it moves to customer finally. So at manufacturing stage, we have different types of prototypes. We call them as buckets. Now in each bucket, we have some vehicles wherein we take the input from the line for various parts and for the processes that are being done on those particular vehicles. So we have some problems, we take them into a sheet, we have a set of meetings taking place, taking the help from all the stakeholders, be it the suppliers, be it the process owners from the plant, be it the top management. So all those feedbacks are taken, and then in all the subsequent buckets, those feedbacks go into as an improvement point, and the vehicle, once it reaches to SOP, or what we call as start of productions, those all issues are being taken care, and proto builds that are being made beforehand are of no use now. But it's a part of process for which OEMs do consider in shelling out money, because that is required as a part of process and as a part of testing for the ultimate customer who is going to pay a huge amount of money for buying that particular vehicle. So from manufacturing the vehicle again goes to customer. Then we have a loop starting from customer, wherein the vehicle comes to the feedback comes to manufacturing for any type of failures that are being associated with the product. So once it reaches, the complaints reach to a plant level, or in this particular case it comes to me, the complaints that are being taken in the field do come to me, or in my case it's manufacturing quality. So they come to me through customer care, and customer quality. Oh yeah, as you can say, maybe in your case, if I take the case of in layman terms, it's the dealerships, the workshops. They bring the they bring the feedbacks to manufacturing for a particular issue that is being associated with their particular product. We take them as an input. So if it's a case of a process failure, we take up with manufacturing, we get the issue resolved. We have to get involved so that the consistency is maintained for that next level or next batches of vehicles that are being built inside the plant. And then suppose it's a case of where the part has failed and it's because of a particular supplier. So the feedback then goes to supplier that it's not because of manufacturing that the product is failing, it's because the component inside that vehicle that is creating a problem for us. So because ultimately whatever the customer is facing is maybe because of manufacturing or the suppliers, he is going to get the warranty for the same, but it's a customer dissatisfaction which we are looking into in next coming slides. Okay, then through suppliers and manufacturing, once the loop is being closed, we have a tracing system wherein these particular things are taken care on consistent and day-to-day basis, because the vehicle is being built and we cannot expect the same type of issues once again. The next batch of vehicle is going to the customer. So this is a loop which has been going for a big period of time, and this is something that has been found successful. So ultimately what we want is the last part of the thing is that the customers giving a feedback, or the customer feedback coming to manufacturing in a positive terms is always appreciated, but something that is not getting the problems that are being faced by customer and coming as dissatisfier for a manufacturing plant or for a brand as big as Tata Motors is against the ethics of against the integrity and ethics of an organization, that it's the things are coming again and again. The problem, once it is coming for a small amount of time, it's decent enough, but if it is coming again and again and there is nothing that is changing inside the plants, it's against the ethics and integrity of an organization, any of the big major OEMs that have been working for making cars. So to take care of these things, we have a system. So the basic ethos of any manufacturing system that is being adopted by an OEM is always a disciplinary approach. So there are subsystems that drive the manufacturing team towards a culture of quality. So these are the five major things that are being taken care in a manufacturing environment for making a product as good as reliable to the end of the life cycle of the product. So those particular five things that we are going to take into account are the people environment. We will be going through all of these things in a detailed manner. But the last point, which is built-in quality, is something which I will be focusing more upon, because this particular thing will be dealing with technical things that are required in making of a product. Those other four things are indirectly helping a product to be in a way that it was designed to. So the first point which I'm talking of here is people environment. The second is standardization. The standardization of each and every process, including picking a nut from the line to bringing the nut to the vehicle and assembling it. So there are particular types of steps defined, maybe two, maybe three, maybe four if the walking is of the operator is on a higher side. But we will try this particular process to be in a two-way or maximum three steps. The next point is short lead time. The short lead time is something the industry has been working upon for a long period of time now. What is short lead time? It is something that if a vehicle is being start building and in the stamping shop, the vehicle should be out from the end of line or from the general assembly to the yard in a shortest period of time. After a yard to dealer is again short lead time, but it's outside the purview of a manufacturing unit. The next is continuous improvement. Now this is something that has been driven from Japanese culture, which is kaizens and elimination of waste. So continuous improvement drives those things that you have achieved a target. That doesn't mean that you have to stop over here. There are always improvements in the processes that can be done, and that will help you in increasing the efficiency of overall efficiency of the system. Now this continuous improvement also drives the cost towards south. It's not that the cost goes toward up. We have to have continuous improvement in place where the cost is driven downwards. Yes, there may be something that that will require an initial level of investment, but ultimately that should bring the the cost of the product down in the long term. The next in built-in quality. Now built-in quality, as the word says, is that the vehicle at each and every process should have a quality that is designed, that is expected as per engine recommendation. And once the vehicle moves to next station doing assembly, it needs to have those things in place that the operator is able to fit his next part without getting deviated from his cycle. And the product built-in quality also states that you should not accept, build, or ship a defect. Meaning, if an operator finds a defect in his vehicle, at the particular stage where the vehicle is being assembled, it should not be the case that he will be passing those particular defects to next station. So those defects need to be rectified at that particular station itself, and it cannot be moved to next station until and unless that particular vehicle is free of that defect. So these five things came from Toyota to General Motors. General Motors had this defined to them, their standards. These particular things are being used by Tata Motors also. So these are the five ethos of, or you can say the five pillars that make a good quality system. So people environment is something that if you have a look at the history, Toyota was one of the first companies that asked everyone that if an operator is not permanent, if he's not being taken care, you cannot expect a quality car from him or a quality job from him. Now that is something of talking of job security, as well as asking him and asking the management that safety, health, and his house needs to be taken care by the company, so that he's devoid of all such pains that can affect his work quality at the plant level. So if you have a look at all the OEMs, the first thing that comes into mind for every one of them is single of one of them is people involvement. Now, what things come into people involvement? Now, the first and foremost thing that comes into people involvement is training and skill. The first line I've mentioned over is special focus on calibration of manpower. Now, every human being has a tendency of doing a particular job in a different way. Now, you cannot have a car made in a customized each and every variant. Suppose in a case of a Tata Tiago, now there is a particular variant that needs to be that needs to have a particular type of feature inbuilt. Now that is something from a customer point of view. Now I cannot ask a manpower that please you ensure that you fit a sun visor on this particular vehicle, and if I don't ask the next operator that comes in different shift, that please ensure that if he doesn't ensure, then it's again a problem for the plant. It's not a problem for the manpower. So I cannot ask him to do the way he wants. We need to ask him to fix a sun visor on this particular variant. That has to be fixed. Now, for fixing that sun visor, there are steps that are being defined on recommendation of the engineering department, and then coming into manufacturing engineering. So that needs to be followed. There are documented process for the same. So each and every manpower needs to be trained, and his skills need to be improved in this particular direction. The next point is manpower to be considered as assets. Each and every manpower that we have in the plant, or we have that is being associated with making of the vehicle, each and every member, maybe it's 2000 or 3000 that are working for making a car as a whole, they need to be considered as assets. Now, from this particular point of view, it's that their health needs to be taken care, their safety needs to be taken care. The next point is skill matrix to be given special attention. Now, what is skill matrix? Now, skill matrix is suppose a person is working at X station. Now, his overall team is comprised of around 10 members. So these 10 members may be working in 3 stations. Suppose in case of X, here is X, Y, and Z. So if a particular manpower is being skilled in X station, he needs to be skilled in Y and Z stations also. Now, what help is the skill matrix is going to give me is skill matrix. I can utilize this for job rotation. A manpower working at a particular location for a long duration of time will always become complacent, and he is bound to create new defects, and he is bound to take shortcuts. So these skill matrix are given to the line in charge as a whole to ensure that each and every manpower is being trained to the particular skill sets that are being required at in our case, in case of X, Y, Z and Z stations. Now this skill matrix needs to have a particular parameters that we have defined in our check sheets that needs to be followed, and once that particular operator has achieved those skills, he can be moved to that particular station where he has been trained and where he has been skilled. Now, job rotation which we are talking here is of that he needs to have a acumen of working at multiple stations. In case there is an absenteeism, I cannot stop the line for that absenteeism. So I need to have my other operators that are being skilled or that have been skilled in earlier days to help me out at this particular station without compromising on the end product. Ergonomic issues to be given prime attention. Now, again, this is a part that has been dealt very, very severely and very, very strictly in majority of the organization. Now, where they have ergonomic issues, such as in case of assembling of an engine, working on underbody stations where we require the manpower to have a look at the underbody station standing below the car body. So that again is not a natural position for any of the human beings. So we have some ergonomic supports for those type of operations, and these things are always given a major attention while building a mass product, because you cannot ask a manpower to assemble 150 cars doing those things in a particular way and affecting his health in long term. So that is not at all acceptable, and that is not at all desired. from any point of view. The next is safety of manpower. Now, safety of manpower we are talking of here is the line, the things that go into making of a car. Now, if I take a look at a particular line or a manufacturing station or manufacturing line, we have some hazards which are not at all desirable if a manpower goes near to those type of hazards. So safety, we have some systems in place wherein the first shield for any of the safety or concerns that do come in front of is always of PPP, that is personal protection equipment. These things we have heard a lot during this COVID times, but PPEs are something that are being used by manufacturing sectors for a long duration of time, and the majority of PPEs involve the basic PPEs that you need to have while going inside a plant or manufacturing unit are always the helmet, the goggles, safety helmet, safety goggles, belt cover, belt protection cover, wash protection cover, safety shoes. So these are some of the basic things that work as a PPP. That and these things are defined in safety manuals also, and these things are designed, and these things are documented for individual stations. So safety of manpower, what I'm trying to say is ultimately the end result that the the manpower that has been making cars should go in one piece as the way he has come to the plant during the starting of the shift. The safety of manpower will always come first while making cars, because it's not a job of 1 day or 2 days job wherein is required to work for maybe 10 years, 20 years down the line. So this is something, the safety and everything is being taken care of. Ergonomic and safety are always on top priority. Then again, we have the next content which we through which we have a look of all those things that are going good from a perspective of quality or safety are in people involvement and data layered audits. So as it is written over here, it's a designated check sheet that needs to be utilized for checking the health of station and the teams. So if a supervisor or if a team leader has a check sheet in which he is maintaining the skill matrix, and in which he has a plan that this particular manpower needs to go to this station in this particular month for getting his training and for getting skill to next level, is always something that we check using our layer check sheets. So those things are defined in check sheets, how that particular document of that team leader needs to be audited, and we ensure that these things are being filled on regular basis, because if these things are being taken care of, the health of that particular station and then the health of that particular team will be always been a top priority for the team leader as well as for the management. Even the improvements that are being done in the stations are being looked at through lead audits. So something this is which we take care during our audits. The next is dynamic checks, if and when added should be tracked. Now, what are dynamic checks? Dynamic checks are, suppose if a defect has moved to next station, or a defect has moved to end of line, or a defect has moved to customer. So at all three times, the things that have taken place are not desirable. So we have some dynamic checks that needs to be written somewhere. We have some quality history sheets that define these, that take these defects from the next station or the downstream processes and take them as dynamic checks, wherein the team leader is required to audit those points on regular basis, ensuring that the systems are in place, that this particular operation in a wrong manner, being done in a wrong manner, is not moved to the downstream stations. A system of necessary layer audit should be utilized for checking the efficiency of overall system. Now, what does this mean? There is that now a layer audit is always being done firstly by team leader. Then for that particular station is done by his group leader. Now group leader is something that he is the one looking after the line. The next we have the shift in charges. Above them we have the shop heads and the plant leadership. So we have a system in place wherein this particular layer audit sheet is first filled by the team leader. So what we need to ensure, or what is a desirable situation, is that for us is that if an observation is being made by the team leader. Now suppose the team leader has an observation of around 10 points, and what we call which we define as something which is not acceptable. 10 points, yes, he has those 10 points, but those 10 points needs to be closed down, so he will be closing those 10 points. Now suppose if his group leader comes to his station and tells that he does his red audit and tells that I have 15 points. We have done the red audit yesterday, it had 10 points. Now I'm going to do that today, and I've done it, and what I've got are those 10 points which are not acceptable. 15 points, sorry. Now what does that mean? That the red audit that was done by the team leader is not up to the mark, because his next level, who is the supervisor, is getting more points, more observations than that particular team leader has got. So that is not at all not acceptable, because the efficiency of that particular team leader is not under question mark, because he has not got those points which his DAX supervisor has found out, or observations that his supervisor has found out. So here in where we call it as nested late audit, because in case of nest, the management is always at the lower point of interaction, or you can say it's something which usually don't interact directly with the manpower which is present in the line. So a team leader is something who is moving if at the bottom of the pyramid, but here in case the pyramid is inverted, so the base is at the top of the level, and here we have team leaders and team members. So we need to have majority of points at the top level coming downwards, as in the shape of pyramid. It comes inverted pyramid is always coming down towards a pointed type of nature. It's always in the case of railroads also, we need to have the observations which are coming downwards as the management is moving upwards. So the top management, that if at all comes to do the layout at particular station, which is being defined in their KPIs also, that they need to come and do the layout audits. So that in that particular case of layout audit, they need to find as low as observation as possible, compared to that the team leader or the group leader or the shop head has found out earlier. So this is something that we call as efficient layout audit structure. There are being improvements done on daily basis, on weekly basis, on monthly basis, that are being tracked through layout audits itself. Now the standardization, the right and consistent way of doing. Now this is standardization, that even if a member has to walk at a particular line, he needs to follow a particular set of steps that are being written on his work instruction sheet. So this is the main ethos of standardization. Each and every step of working has to be documented, and that particular step has to be done by that operator in that particular manner as being defined in his work instruction sheet. Now in standardization, the first thing that comes is every time 5S. Now I sincerely hope that everyone here is not new to 5S. 5S is a methodology used by Japanese, and it's something that an organization always strives to go for. That is 5S. Each part or each thing has to have a location, proper tagging, and it needs to have a proper defined place, whether it may be doing working of the line at the running of the lines, or maybe once they are going for the day off. So the things that are being defined to have a particular place, they need to have a particular place. Now there are some rejected material always from coming from supplier, not supplier, because they give us the right part, but sometimes they have some problems in their particular part. So, and even there are some problems that go into making of the product, end product, that is the vehicle which we are talking of. So there may be some rejected material that may be lying, but they need to have that particular location for each and every rejected material with proper tags, That means that they need to go for scrap once they are moved outside of the plant. Now the thing that is required for this is because that we need to have as much low as the rejection at our line side. So once the rejected material is being seen and it's being tracked easily, you can go for next level of improvement. You need to have that data that reject. We have this particular amount of rejection. Maybe it's for supplier or maybe it's due to process. Then also we need to have a proper guidelines and proper planning in place to ensure that this particular rejection goes down on each first and at all a monthly basis, then on the weekly basis. The next is segregation material and area defined. Suppose I have a part that comes to my line and that is not to the specs that has been defined for them through engineering drawing. So we need to have a segregation material, the okay material that needs to come to line, and for that not okay material we have an area defined, which we are telling us that return to supplier. So in case that return to supplier is there, the parts need to move to supplier in that particular manner, and the okay material needs to be segregated in one place, so that is considered as okay, and that can be supplied to the line side. So segregation material needs to have have an area defined for itself, so that it comes to line as and when required. The next is line balancing using wall chart. Now line balancing is a part of industrial engineering. What is line balancing is, we will be going through these things in next slides. So we will be taking up this in next slides. The next is standardized work with control document. Standardized work, which I am talking of here, is the control document is something that can be changed in a day. Suppose a team leader finds that or group leader finds that this particular step of working can be changed. We can have some good amount of efficiency and quality going forward. So we need to change this particular step for achieving these gains. But it's not that he can come on the line and change that particular thing as and when required. It's a part of control document. Now, what is control document? It's something that is being controlled by particular department or particular designated person at the organization who has the overall control for these things. Now, this particular input from team leader or group leader will go to that particular person or that particular department, who in turn will engage and do the time study for us at the line side, and then he will give a go ahead for changing that particular step in the next iteration. So once the next iteration goes on, the industrial engineering department is again who is working to ensure that this particular iteration will now be considered as a control document. So that he will have a master copy, or we can call as control copy, that once one copy of control copy will come to the line, which will be stamped as control copy. So that will move to station. Now these things are always again part of lead audits also, to ensure that all the documents and all the processes that are being done by that operator is in line with that control document or control work document. The next is visual management, all documented standards. Now, visual management is, we need to have, suppose if today I find a mirror which is not okay, I have some waviness on the mirror. So, but the operator is not able to identify. He looks at the part, he takes care that it's a good part. He is not having a damage, the part is not having damages, and he will ensure that it goes with the product. At end of the line, or at a quality gate, or at the subsequent station, the next operator is able to find that that there is waviness at the mirror level. So what he will do is, he will identify that as the same in the history card of the vehicle. The vehicle will get offline, and then the mirror will be replaced, and the vehicle will move forward. Now that particular defect, the particular defective ORVM would have been identified at that particular station where the person was assembling that particular part. Here in case, it's a case of ORVM or outside rear mirror. Now we will have a visual management control at this station, which will ensure that he has a photograph of the good product, and he has a photograph of the not okay product. So what he will do, what he will utilize this document as such. Suppose he is going to assemble the next RVM, he will have a look at document at what was earlier considered by me as okay is not the case, and I need to have a look at this particular mailer for this particular waviness. So he has one benchmark with him as a document, which he will use to ensure that he doesn't fit a wrong RVM the next time. So this is just an example of visual management. There are lots and lots of example of visual management that we can utilize. So this is just a basic example of visual management which we have as a control, and there are lots and lots of opportunities that inside plant we have for ensuring the visual management control as a way of doing a regular job. Now standardization. So this is the basic of each and every OEM that has been working today. Now this is management by TACT, and we will be going by just a calculation over here. This will be helpful, and this is going to be interesting study for each of you that are sitting with this in this presentation. And MBTT is management by takt time. So this is just an example how the production is being planned for a month-on-month basis. Now this is the what we're telling here is the first line is customer demand. This is 10,000 units per month. So we have taken a case of a scenario in which. So first, before I start this presentation, before I start this slide, it's just for information that we are looking this picture from manufacturing perspective. This is not something that will this will not be something that will utilize as the input for our suppliers. So this is only for manufacturing perspective. So suppose there is a demand of 10,000 units per month. So marketing gives a demand to management that we require 10,000 cars this month, or maybe not this month. We require 10,000 cars the coming month. So they have a subsequent plans in place. Now that we know that we have set a plant wherein we can easily make 11,000, 12,000 cars a month. We can pull out this amount of cars from the line. So for this particular month, if I have a look, the marketing says me that you need to have 10,000 units this month. So I will start my calculation. So the first thing here is that I have 16 hours because I am working in 2 shifts. So I have 16 hours. I don't have the manpower for 3rd shift. So I have 16 hours in a day. The next thing is that I have 24 days. So this is just a scenario. So there are 4 weekly offs and there are 2 public holidays. So I will calculate, yes, I have 24 days for working. Then I will calculate that I have 24 into 16, 384 hours for working. Now I will calculate that for 384 hours, I need to produce 26 jobs per hour, or 26 cars should be rolled out per hour to achieve a figure of 10,000 unit or 10,000 cars for this month. Now I will calculate that, yes, I have 26 units, 26 jobs that need to be pulled out. So I will decide what time I have for particular station to do their job for me to achieve those 25 jobs, 25 cars per hour. So my available takt time is, this is known as takt. The available time for me is 138.5 seconds, or this is for individual stations. This is not for any unit. This is or for a line. It's for the whole station. The conveyors will be moving at this particular speed from a fixed point stop to the next fixed point stop. Now this fixed point stop is the periphery of that line of that particular station. The vehicle moves. The vehicle comes to a particular station at particular FPS, and to the next FPS, the vehicle is to the next station. So the operator has to complete his job to the starting from the first FPS to the second FPS. FPS here again means fixed point stop. Now this is the overall time that I have, this 138.5 seconds, but this is not something I can take for making the car that the operator has 138.5 seconds. I will ask him to utilize all of his time in each of his steps and give me in car 130 give me a ready product in next one from your station in 138.5 seconds. This is not acceptable because we have some more factors coming down. And suppose, which is a standard practice in the majority of the OEMs, it's that we consider it as 4% as downtime factor. Now, for what is 4%? It's 4% is that we need these things to be given to maintenance. Suppose there is maintenance downtime. So I have taken and a downtime factor, or maybe you can say leniency factor of 4%, or you can say in engineering terms as a safety factor of 4%, that I have the 4%, I will give this 4% time to maintenance. If in Y I have a maintenance problem that is going to stop my line, so I will take down 4% as my downtime factor. Now I will minus that 4%, so I will be coming at 133 seconds. Now it's not that I will be using my operator to the full loading capacity, and I will be telling him that each of his steps is defined in such a way that he will be utilizing is 133 seconds, which he has been allotted. No, I will be loading him to 90%. Now, what is meant by 90% loading is, if suppose I have some steps that define him working for movement, walking down the line, taking the part, and I ask him that according to my study, you have 4 seconds to do this thing. Now, I will ensure that each and every operation of his, starting from picking the part, bringing the part to the vehicle, torquing it to the capacity, talking to the desired torque, I will be doing a time study, and I will be ensuring that his work gets completed in 119.7 seconds, or it is approximately 120 seconds. Now, this is because I will be giving him that 10% that I have not loaded him as idle time. Now, this will refresh his mind, and he will be ready for the next job. Now, this 10 seconds or 12 seconds I am giving him just for him to move his vehicle to next station and have his idle time. The desired factor is always around 95-96%, but not more than that. It is always undesirable to load a manpower to above 95% of his cycle time, of his available takt time. Now, this is because you cannot load a manpower to the limit, and because then he is going to create some problems in the case of quality unknowingly, which is again undesirable. It's not that he will be doing these things knowingly, but this is the normal tendency of a human psychology, that by working continuously without any break, even for 10 seconds for next vehicle, he is going to create a problem for overall quality and maybe in efficiency in long duration, because if he creates a quality problem, the line is going to stop maybe more times than that is being desired. So 119.7 seconds includes everything. Then again, we have again a concept of weighted average cycle time. Now, this is decided based on variant and model mix on a particular line. So suppose if a line is being run and there are 3 models being built on a line. Now, these 3 models will have different variants too. Now, if it's a basic model, or if a base model, there may be some features that may be missing, and there may be some operations that may not be being done on this particular model. So I will be taking out the model mix. How much percentage of that particular model is being built, or it is being desired by the marketing for me. So I've taken a case of 3 models, 3 variants here, which is X, Y, and Z. So X is a basic model for me. The Y is a mid-tier model for me, and Z is the top-end model for me. So X is something which we are not going to provide a sun visor. But now this is 10%. Now 10% is the model mix. The marketing is asking me, yes, that you are making this much of amount, this much 100 vehicles. Out of that, only 10 vehicles that are required for me are base variants. The Y is 30%. Now this is the mid one. So the marketing is asking me out of 100 vehicles, 30 vehicles should be Y1. And the Z, and he is asking me that we need to have 60 vehicles out of 100 as top end. Now I will be giving, suppose in case of base, it's 0%, 10 seconds for Y, and subsequently for Z. So I will be taking this as my benchmark for loading for that particular cycle time. In my standard document, I will be having 3 columns for, because I have three models in each. For each variant, I will have some different times, and I will be calculating that as my weighted average cycle time that is being required to complete that whole process or whole documented process that is being written on that vehicle for that particular vehicle. So this is the concept of weighted average cycle time. Now, this is standardization, which we have committed, which I have tried to cover as much as possible. The next is short lead time. We will not be doing much time at this point also, because this is something that is not related directly to quality, but this is something that is related to the efficiency of the system. The first is FIFO, which is first in, first out. The parts that are being supplied to a manufacturing unit, and that ultimately that is being supplied to the main line, should always follow first in, first out. The first part that come inside the plant should go inside the vehicle, and the last part that is coming inside the plant should go to the last car that is being assembled on the line. The next is sub-assembly and offline operations should be as much close as possible to the main line. Now, in case of, I will give an example. In case of ORBM, we have some sub-assembly units. In case of bumpers, we have some assembly units, wherein not exactly units, they are particular stations which are held close to the line, because the bumper has to go to that particular vehicle in a short duration of time, which should be as low as possible, and for that it's need to have a system wherein that particular part moves to line in shortest way, which is, I'm talking of moving from one station to next station. So these stations are always offline stations and not on the main line. So this particular station should always be as much as close to the main line. Then next, to doing locations for quick changeover. So if I have a second model coming on me for this next work or next job, I need to have different tools. If I have for different models, usually we prefer to have same tools for different models, so that we can have a quick changeover. But if and when we have different tools for different models, then they need to have being in close proximity to each other, so that the quick changeover is as quick as possible. Now, this is again a kitting process. So usually what happens, we have just in here, I will give a case of door line. A kitting process. What is kitting process? If I have a particular operation, if suppose I have a dashboard which needs to be assembled at the offline side. So what I will do is I will give him the dashboard. I will apply a kit as a case of a basket, or a basket with different tags and different sub parts inside that. So that basket will have all the parts being put inside. Once the dashboard is moving, the kit will also move with that dashboard. Now what will happen is that the operator will be taking the part directly from that kit and putting it in or assembling it on the dashboard. So it should not be the case that once the dashboard reaches to the end of line where it's moving to the main line, it should not be the case that I still have some parts inside the basket, maybe even a screw or a nut. So it's not desirable. So what I'm trying to do is I'm helping the operator by giving him some direct kitting parts in place, so that he can put these parts directly on the vehicle or directly on the sub assembly that he's been doing. So this will ensure that he has some convenience in place, so that he doesn't have to think at all or at all times that what needs to go inside the dashboard. He has a training with him, but still he has the convenience that even if he has those skills, he's not going to miss, because we have an added convenience for him. The supplier part pick up on time. Now this is again not related directly to manufacturing. It's something that we have supplying a supplier team at our place, which do a milk and pick up for every supplier which are in location. So that what this particular line is talking about is of the schedules that needs to be maintained and that needs to be adhered. The next is min or max, out of stock and overflow process, well documented and understood. Min max is the set. Suppose if I have a JIT process, which is just in time. Now, what is just in time is in majority of OEMs case, it happens that the big parts like bumpers, the engines, the powertrains, the dashboard assembly, the seat assembly are always in just in time. That as and when required, I will trigger an order in the morning for the supplier that has those particular parts with me, that has those particular parts at his location. Now, what he will do is he will get those orders in the system. He will start assembling, and he will ensure that this particular part, that this particular seat, which was being asked to by us or by the OEM at that particular time. Suppose at 12 p.m. That particular seat needs to be on the line at that desired location, so that that particular seat goes into the vehicle. So this type of JIT processing being used. Now for that particular process also, we have min max defined inside the plant, because the most valuable thing that is inside the plant is always the space. That is always that something that is costliest of every, as an asset. It's a costliest of all things. So we have a process in place of min or max, that is, it is that at a particular period of time, I need to have a minimum of 6 parts and maximum of 10 parts, and the supplier cannot go above 10 parts at a particular point of time. So that is min max. Out of stock situation should not be there, and if it is coming again and again, it should be documented. The data needs to be analyzed why it is happening again and again. And similarly, case of overflow, suppose a particular part is being overflowed and it's not being followed for a min or max, and there are deficiencies in process, that needs to be documented as well as analyzed for their closure in subsequent days. So next is well-defined process for changing pull cards, line side labels, and reorder points. Now this is something that usually happens when we have a change in model mix changes, or suppose if I have a particular variant which is going to have a particular feature deleted or being added. So those particular things need to be changed. These are changing pull cards. Some pull cards are something that line operator usually gives a trigger. This is for the forklift operator or the line that the supply line that is helping him to get those particular parts at the line. So this changing pull cards and line side labels and reorder points, this is something that usually is being taken care during the initial launch phases. Even if there are change in production volumes, there are subsequent change in production volumes. Now this is not subsequent, this is substantial. If I have a substantial change in production volumes, then I will try to align those things so that to the new production volumes that we are targeting for should not have a problem of overflow or min max. Now the last thing over here is part requirement changes. Suppose if a part is being changed for the next batch, or there's a change in design. So maybe I will decide a cutoff that this is the last vehicle which is going to have this particular part. After this, the new part or the desired part that is being recommended by the engineering will be used from the next vehicle. So I will release a cutoff, and I will ensure that the next part and that particular part that is being used from the next vehicle goes into each and every vehicle, that for which I have given a cutoff, or for which I have given a breakpoint, that this is the last vehicle and this is the first vehicle for me. So now this documented process and documented systems will help me to track and trace it in the field. If there is a failure, if there is failure of that particular part, that can be traced by me, because that is being documented in the system. We have a system which is server, which has its data in the servers, and this can be accessed by many of the line in charges and many of that top management who have that direct access to that particular data. So we have a data, we have a traceability in place. When any particular part, or if it's a critical part, critical to quality, critical to safety, we have the tracing for each of those parts, so that if it's a failure in field, we have that batch quarantine, we have that batch in our track that this particular batch needs to be changed in those vehicles, and we have a track that how many vehicles have passed with that particular defective part. So this is the just an basic of short lead time. Now this is very much important. This is continuous improvement. Now, this is the way of life for any organization. Maybe it's an OEM or any of them, because continuous improvement ultimately leads to a decrease in cost and an overall efficiency of the system, which is always improving. And the continuous improvement is something which will drive these things. Now, continuous improvement always comes when all teams are involved. So we have some things in place which will ensure, such as in our case here, it's always led audits, which will ensure that the teams are involved for getting the improvement. They have some targets in each line operator. Each line worker has an target of suppose 6 improvements that needs to be done by him, 6 suggestions, six kaizens, maybe that. So these are the some benchmarks that he needs to have these things done, and there is a compensation involved for him. Now, if I involve a compensation for that particular person for that improving the efficiency of the system, he will be involved in a greater manner. So compensation is one thing. Giving him targets that he needs to track himself is something, again, a part of team involvement. Feedback, feed forward, line and field. Now, suppose if a defect moves from a one station to next downstream station, and it's not caught anywhere, and it moves to field. Now, what happens is, again, once it's moved to field or once it's moved to customer, it's something which is again not desirable, and ultimately it affects the brand image. So we have a system of called as feedback, feed forward. Now, feedback is, as we all know, is feedback is something that subsequent stations and the field that has found out, the customer or the dealer that has found out, that feedback will come to that particular station where in that process was done. So this is a feedback process. Now, what is feed forward? Now, suppose I find a critical defect at my particular station wherein I was assembling it, or where at the subsequent inspection station where I found out. But I have a doubt that this defect has skipped from my checks also, and it may have rolled on to the next vehicles that the vehicles that have passed from my lines, and maybe to even the yard. So what I will do is I will send a feed forward. There is a mechanism for that feed forward. Now, feed forward will give a trigger to the next station that this particular defect may come. So be vigilant and try to find that we don't have a bigger batch for this type of defect. Now, it depends the type of defect that is being moved from that particular station. If it's a very critical defect, the whole yard will be purged. The whole yard will be checked for this particular defect, and if it's being be found out, then a trigger will go to dealers also that this is a particular batch of vehicles that we suspect will have this particular type of problem. So kindly get them set and kindly get them repaired, so that the vehicle moving to customer from his dealership will does not have this particular type of defect. And this is also a trigger for field recalls or field actions, which you may be seeing in the newspapers and the internet, that particular fault company is ensuring to have going to for a major recall. So that is something. The field actions are again something which are not desirable, because it's ultimately adding on to the cost, because the dealer is not someone who is going to do a charity of repairing that defect without charging any money. The OEMs or the plant or the brand is accountable for the same, and which is again a cost, and which involves a cost and which is not desirable. Problem solving processes, documentation formats. So this is something we have. We have tools, we have some formats, designated formats, which have predefined structure of problem solving. Suppose I get a problem, then I need to have a that particular process of using that format, writing down each and everything, writing down the inputs of the team members with whom I am working, going for that 5 by process, using the 7 tools, using the fishbone diagram, going for the 7D documentation private process. So these are those things that usually go for problem solving. Now, problem solving is a part of continuous improvement. Because why continuous improvement? Because I found a problem. I'm going to ensure that this particular problem is not repeated next time, and I'm using this documentation for giving it to next stations, and for as a documentation for myself, that if I'm not here and this defect gets coming again, then they have that particular document with them, which will ensure, which will help them out at that particular time, that they need to have this solution in place, and they can get to do the making of the product in a faster manner. So this is part of, again, part of continuous improvement. Target review boards. So what is the target review boards is, if you don't have a target, and if you don't have visual control for the same, and you are not reviewing them on regularly basis of frequency, on a defined frequency, then you're not going to achieve the target, and maybe you are not able to achieve those targets because you don't have that seriousness, because you don't have a visual control. So we have visual controls wherein if you don't achieve a target, it's always highlighted as red, and red means that it doesn't mean that you are going to be penalized for the same, but it's always means that you are being highlighted, you are being asked to improve upon that. So once it get red for 1, 2, or 3 months, then it's a problem for everyone, the team leader, the group leader, and it's being escalated to next level, so that yes, I am not able to achieve, please support me. And if it's required in an extreme condition, then only those targets are reviewed, and a leniency is given that yes, you have problems and you cannot achieve this target this year, so we are going to get those targets revised, and then next year we can have new targets uh, from where we are going to close this year. The next is end-on boards, problem-solving system. Now, end-on boards are the concept that Toyota brought into picture. Now, this has very good story behind that. Toyota's engineers went to GM plants and Ford plants in USA. What they found was that an operator, if at all, was finding a problem with this product, of he was not in that particular culture where they had an option of stopping the line and fixing that problem and sending it to the next station. Now what happened due to this was that operator did not have time to fix his defect or fix his vehicle, and the vehicle moved to next station, and he will leave that vehicle as it is. The next vehicle he will do the job again, and if that particular problem is coming again and again, all those vehicles that were being in that particular period will have that problem, not now, maybe in the field. So it's going to have some problems at the end of the day. So what they had was a system of end-on boards. Now what are end-on boards? We have a visual display of electrical lights, which an operator, if he finds a problem and he's not able to complete his job in his duration of time, he will pull that cord that he's being given to his station, and the lights that are associated that particular end-on will light up, and if a siren will move throughout the whole assembly unit, that line has stopped from a particular station, and there is an end-on call which says that he requires support. So this is the visual control that I can have. Once I move outside line, I can see that which station has this problem. We have boards, we have target boards which highlight me where is the problem in that particular shop. So these are the visual controls again. So end-on boards, end-on cords, end-on lights are something that are usually required as a tool for problem solving. And this, if a substation has end-on calls again and again, and that is becoming as a bottleneck for me, then I can have that data from the system on which particular station are giving me are acting as a bottleneck for me, and I need to improve on which part of that station so that my efficiency and my output is not affected. Again, which we already taken care of, are fixed position stops, that are markings to be made, and that markings need to be adhered to. If and when there are problems with the operator skipping his steps or operator moving to next station while assembling his vehicles, that needs to be taken care in part of continuous improvement, and this needs to be improved so that he is able to do his work in designated time. Maintenance schedules maintained and followed. So maintenance schedule should be made and followed. There are some PMP schedules that are being put in the system, and that gives a right time trigger to maintenance team that a particular part has its maintenance duration defined in next 2 days. So kindly note of the thing, and kindly take note of the same. So what maintenance team does is they take stock of the situation. They they give a trigger to that the team members that are working with them, that this is the this is a schedule that they need to do for it for today. They will follow that schedule, and the same trigger will move to the system that this work is being completed. So we have a documented system, we have a particular system wherein we have the records that this particular machine was being done at this particular point of time. It was under maintenance, and that main machine was under maintenance, and the backup machine was in process. And if it's a small process, then during the third shift, wherein usually we don't have the production in our case, then in that particular thing, in that particular duration, the maintenance team is always in the third shift, and they will ensure that that particular machine which was under maintenance or which was defined under maintenance schedule and still working okay, they need to have their PMP done, so that, and in a way that once the shift start again in the morning, early morning at 6:30, the machine is on track. Voice of customer, VOC tracking and closure. Now you may have heard the name of JD Power. Now what is JD Power? JD is an independent organization that takes the feedback from the customers in during the initial level, during the long term level. They take the feedback so from the customer, and basis of that they have some rankings in the mid. So VOC here gives a indication of JD Power and all such type of independent organization or third party organizations. And VOC is also it's a verbatim or a complaint referendum from dealers or customers, which we track and we close, and then again we track. Suppose it's a problem that is coming in many of the vehicles, we take care of them, then we track whether after that particular win or particular vehicle that the problem is repeated or not. If it's not being repeated, it will be taken for closure, and it will be ensured that those actions that were taken for that are in place on consistent basis. So as lead audit, we have some documents, or we call it as PPAP, so that those things are taken care in PPAP. And if it's a process problem, then it's been taken care through lead audits and work instruction sheets, which are again standardized. And as I've already told you, there are control documents. So the next and the most important thing that will be very much important, and we will be taking some 15-20 minutes more for this, and then we can go for question answer session, is built-in quality. Now, why I am being taking this built-in quality as last, which is ultimately the first thing that should be taken, is because without that base work of those four particular absolutes which we have already talked of, this built-in quality is nothing. It requires support of each and everything, each and every support functions before a built-in quality is achieved. So the line bureau that usually says, which is rightly said, is because in the end only customer satisfaction matters. Whatever you are making, whatever product you are making, it's always defined to the needs of the customers. And if your customer is not satisfied that particular product, then rest assured that he is not going to come back. So customer retention is something that built-in quality always ensures, and built-in quality is something we always try to tell that yaar ye gaadi awaaz kar rahi hai 5 saal baad. So those are things that is rattle is something that ultimately goes with the durability and reliability of the product. And we always take care of such thing that reliability of a particular product should not take a hit while the vehicle is being built. Reliability is something that is built in for a particular product that is being designed, and built-in quality parameter ensures that such things are taken care of while the vehicle goes to the customer, and the customer is happy even after his warranty period of say maybe 5 years is completed, and he's driving the vehicle as a new vehicle even after 10 years. So that is always desired. And built-in quality is something that drives it. Now, built-in quality has 3 major things, and first is product quality standards. Now, again, product quality standards are something that come as a document from engineering. We try to modify it as per the manufacturing, because in engineering it is always given as a drawing, from which we take it as those parameters in our check sheets as per quality standards. This per quality standards, we have a team of quality engineers which we call as quality engineering department. This quality engineering will have those per quality standards documented and a master copy built with them. From this master copies, control documents will be generated, which will be stamped and given to the stations wherein that particular quality standard needs to be maintained. And usually those are those stations wherein the vehicle that particular operation is being done, and the subsequent quality gate or the quality station where that particular part or thing will be getting inspected. So this document is one of the major documents for quality departments, and this is we usually call this as our Bible. This is our Bhagavad Gita. This is something that needs to be taken care in utmost manner, because this is ultimately that is being driven from customer to manufacturing. The first loop is engineering to customer, engineering to manufacturing, and then manufacturing to customer. But these fits and finish, this quality standards, whether it be paint, whether it be fits and finish, whether it be noise from engine, from the rattle type of noise from engine, from the body, that everything comes under quality standards. Training and calibration of operators. Now this is something very important. Training and calibration of operators is being done through the skill matrix. During the skill matrix, during the training processes, the product quality standard document is a very important document, and is given as a reference to them in their operator instruction document. And once the team leader is giving training to that particular operator who is going to do that operation for them, that particular PQS or product quality standard document reference will be given to him in that particular step, where he is expected to follow that product quality standard. Suppose if a vehicle is being built in BIW, or you can say body in white, which is body assembly. Now he is asked that door to fender or door to door, front door to rear door, he needs to maintain a gap of 2 mm. Now what will be done in his WIS is that he needs to follow a gap of 2 mm. But what PQS will tell him, that product quality standards will tell him that yes, 2 mm is the desired thing, but if you're not able to take it to 2 mm, yes, you have spec of 2 or plus or minus 1, 2 or plus or minus 0.5, whatever it is. And then we have a problem of where we call as A gap. Suppose the gap at upper level is 1.5, the lower gap is 2.5. Now this is well within spec, but is it acceptable to as per product quality standards? Now this is something that will be written in product quality PQS, whether it is acceptable or not. Whether there is a situation that is wherein I have a V gap, the situation is as inverted as A gap. Now in A gap, I have a problem wherein the gap at the upper location is lower, where in case of V gap, the gap at the lower portion will be in lower side. So that is something which will be clearly mentioned PQS, that it is required or not. Now this is the PQs are usually related to the perceived quality of a particular product, the gaps and fits, the velocity or the door effort which is required to close a door for a vehicle, the effort that is required to open a door of the vehicle. I cannot check the door effort for each and every vehicle, because that is not something that I can do in running line. But we have some random audits in place who will check that this is acceptable or not, and based on that a loop is formed of feedback feed forward. And usually it's a feedback wherein the operator is told that he needs to adjust the latch in X or Y direction, up or down direction, or out, taking in the latch outside, so that a particular vehicle flushness, gap and door effort is maintained. And he will be given some reference bodies with him through which he can calibrate himself, and he is given those calibration with the expert or defined operators. That calibration is being done, and that particular skilled manpower will go onto the line to ensure that PQS standards are, product quality standards are maintained. for each and every vehicle that is being passed through him. Each stage of inspection process for quality standards based on engineering recommendation that I've already told you. The next is manufacturing process validation. Now PFME is this. I think everyone of each of one of you have gone through this. This is PFME is when we were building the Baha vehicles in the year 2012, 11, we were. I was the one that was involved in PFMEs during that period itself, and I've been doing these things in my present situation, my present work process too. Now, what we do is we identify the high risk processes, high risk operation, high risk processes through PFME. Now, PFME has three particular parts, which is severity, occurrence, and detection, which we usually call as SOD table. Now, SOD table has some values. Suppose the severity is of 10, the occurrence is of 5, and the detection is at a particular 10. So we will multiply. We will have some value, and that value which we get out of this 3 multiplication of SOD, it is what we call as RPM. Now, after this multiplication, the value which we have got is RPM is, suppose it's over 120, it's above 130, 140. So that is undesirable situation, because the process is high risk. Now, using that RPM rating, we will tell that this process is high risk. And suppose the severity is defined by whether it's a safety, legal, or customer irritation. If it's a customer irritation issue wherein it's not such obvious, the severity will come down. But if it's safety and legal, the severity is always 9 or 10. So if it's a safety, it's always 10, and for legal also is always 10. But it's something that it's a safety and legal, but yes, the severity is comparatively that customer is not going to have an accident, but yes, it's a safety feature and that cannot be compromised. So then it comes to 9. Other feedback like that is a customer irritant, then it will come to 8. So that is again not desirable, but it says it has a severity rating of 8. Then we can have occurrence, whether that particular problem will come again and again. So we have some old benchmark documents, old benchmark processes, which will help us to identify whether this particular problem can come or not. If it's coming, if it was coming in earlier vehicle, then occurrence will automatically go towards higher level, and this particular document can be revised as and when we have problems coming up in the lines. So this is SOD tables are defined based on same. Then detection as such is again detection whether if it's a process failure of or this particular part has not been fixed properly, whether I can identify in downstream stations or not, whether this can be identified quality gates or not, or quality stations or not. Then again we will give a rating of detection on that particular basis, and then we will have a SOD table, and then subsequently RPNs. So this PFMEs are completed during launch phase. Then they are reviewed on as and when we have some problems. Suppose I have a problem of variant mismatch occurring once so many times in a week or maybe a month. So that PFME for that particular operation will be reviewed. It will be updated with new actions so that variant mismatch is not happening again, and corrective actions are taken so that this particular defect at least first goes down to coming to my stations, and then subsequently it moves towards 0. So this is the desirable situation. Process control and error proofing is again process controls. Error proofing is always desired. Sorry, it's always desired. Error proofing is always desired for all of those operations which are critical in nature. Just in case, I will give you an example of wheel nuts. Wheel nuts are very much critical to quality, because if a wheel nut is not properly tightened, the wheels are going to come off. So all the 4 nuts that are being tightened for that particular vehicle, they are being done using the tools which you call as DC tools. Now these are DC nut runners. Now what DC nut runners do is that they have an interlock with the line. So suppose a vehicle is being passed from the line and it's not the nuts are not tightened, and the operator forgets to tighten the nuts. So what we have a logic inside the DC nut runner is that if it's not tightening, if it's skipping the operation due to any of the reasons, the line will stop, and there will be a siren above his head, above the operator head, will be giving him an indication that he has missed the operation. So he will do the torquing operation using his DC nut runner. Now DC nut runner, the DC nut runner has a tendency to take over the torque. It's not that direct current. It's a airproofing tool. It's a DC airproofing tool. The the data from that nut, the torque that has gone inside that tightening of the nuts will be taken inside the servers, and that will be stored in the servers, giving an indication that yes, the particular vehicle was tightened with this amount of torque, and this particular amount of torque has gone inside that wheel nuts. Now suppose there is a case in the field related to wheel nuts, then yes, we have the data, we have something that which we can look up to for analyzing the data. And this in coming months, there is something that is happening at government level itself, which we have got some notifications which says that traceability of critical parts, such as the steering, the PAP covers, which is passenger airbags, the driver airbags, the universal joints that we are using for steering tightenings, those traceability should be there in the system. And DC nut runners is a part of that it's providing traceability for majority of the critical or safety operations that we are doing. This is majorly the top priority for setting up these DC tools. Actually, this requires a huge amount of investment. So the priority always comes to first to safety and quality. So after that, we can go for next processes. And a DC nut runner can be utilized for multiple operations also, with small modifications. But still, it's a costly affair. And but OEMs are using these things because this is required to maintain a minimum level of quality. The next is action should comply with engineering and risk assessment requirements. So PFMEs cannot be reviewed or updated without taking into consideration the engineering parameters. You cannot deviate from your engineering parameters and go for your PFME updations. No, you cannot. They are locked. And if we have a doubt, or if we do a change that is not up to the required specifications of engineering, it will lock up the system for you, and it will not allow you to do the subsequent changes. And yes, if you change the actions and if you go for something that is feasible, then the system will allow you, and the PFMEs can be taken for corrective actions. The next is operation readiness. Now this is something very much important. If I have to look for a new model, or in case of COVID, what has actually happened that we had our line shut off for more than 2 months. We had a shutdown, and then we have pre-startup activities and startup activities in place. We have a defined check sheet for each and every station. The team leader has to move through every station, ensuring that his tools, his gauges, containers, his methods that are defined by him in his WIS are well in place, and his station is up to the mark, for ensuring that the vehicles moving through stations are defect free. And they, in case of torquing operations, the torque tools that he is using, maybe the hydraulic tools, hydraulic nut runners, or torque tools or torque wrenches that he is using, is stickered with the calibration stickers at the defined frequency. And we cannot just start a line in a day. We require a backup of operations that are being done just before the assembly of the vehicle starts. So it's a long-term process, whether it's a BIW, it's a paint shop, or it's a TCF, or you can say general assembly lines. There are some practices, and there are some check sheets that needs to be followed for shutdown and startup activities. Suppose in a case of Diwali, if you have a long vacation of 7 days, then even that in 7 days, it's a shutdown. An official leave of 7 days for a plant is always considered as a shutdown. Sometimes the shutdowns occur during the last week or maybe last 2 weeks for December, wherein the plants are shut down for maintenance activities. Then this shutdown and startup activities are being done for ensuring that the vehicles starting from the month of January are again to the level of quality or level of perceived quality that was there just before the shutdown. And the last line here is line rate changes. Now, what is line rate changes? Again, it's again dependent on the manufacturer. It's again dependent on the marketing. What is the current month production requirement that has come to the manufacturing? So, if it's a major line change requirement, we have changes in the line speed. Then those things needs to be taken care during line rate changes, and operation readiness should be there. And once the operation readiness is there, only then I can go for line rate changes. The next part is process capability studies. Now this is very much important. If I'm using a torque tool which is deriving a torque to me of 10 Newton meter. Now this particular torque tool is being calibrated to give me a reading of 10 Newton meters. The torque tool should ensure, and it should be ensured through torque tool, that it is delivering that reading of 10 Newton meters to each and every vehicle, or say lot of 400 vehicles or 1,000 vehicles for which it is being calibrated for. I cannot have a torque tool which is giving me a torque value of 10 today for this batch of 200 vehicles. Tomorrow I come again, I use this torque tool and it's giving me a value of 6 or 7 Newton meters. This is not acceptable, because that particular torque tool was calibrated for 10 Newton meters. So we have CPK values, which is again process capability studies, which I think you may be knowing of. This is process capability studies are being done for each and every torque tool which is being used online. These are maybe the hydraulic tools or pneumatic tools. Majority of cases it's a pneumatic tool for which we go for process capability studies. And when that particular tool passes through that process capability studies, only then it's being given online with a sticker that shows that this particular tool is being calibrated for next 5-6 months, maybe 1 year, whatever may be the complexity of that particular tool. Manufacturing validation is always related to man, machine, material, method, and environment. What is manufacturing validation? It's always once the prototypes are built online and they have started to come online, and we are moving towards the start of regular production. Then manufacturing validation needs to be done for related to, it's not only to the part or assembly process, it's related to the man, machine, material, method, and environment. Now, in case of machine, suppose it's a brake reservoir filling machine, then the validation should be done for the line speed, wherein the brake machine has a time wherein if I have a cycle time of 120 seconds, then that brake machine has to ensure that brake filling is being done in 115 or 120 seconds. That was defined. Usually we have a practice wherein we give a leniency to machine of around 10 seconds during each operation cycle, so that the machine has some idle time before it moves to next operation. Relaxation, this is what we call basically as relaxation time. So if it's a material change also from supplier, now this goes even to tier 2 supplier. Now what is tier 1 supplier? Tier 1 supplier is something who is giving a material directly to me. Now that particular tier 1 supplier will have the next supplier which may be giving him the child parts. Now, so if there is even a change in location for that tier 2, even tier 3 supplier, that is documented through our supplier quality assurance process, and that comes to us as a document for validation, wherein we test it, we inspect the vehicle with that particular part in a batch of first 1 part, then 5 parts, then 25 parts. And if in this particular process of 1, 5, and 25 parts trial, if it's okay, then yes, we will give a manufacturing validation, yes, that it's following our run rate process and it's giving us results in all the particular 1, 5, 25 process. And engineering has given a document which we call as green report, which says that this particular part will not fail during their reliability. This particular part has not failed during their reliability process, and yes, you can utilize this online. The next is run at rate capability. So I've already told you production trial run goes for 25 parts. Run at rate capability is tested with 25 parts, with 5 parts. Yes, I am getting this. I'm using this part for continuous for 25 vehicles. I'm using this part continuous for 5 vehicles. I'm not getting any problems, and my line is not stopping, and I'm able to complete my job in the designated time that is allotted to me. So yes, I can give a go ahead for this. Then manufacturing gives a go ahead. Quality inspects according to the standards that they have been given for the particular product. If it's for that particular part, yes, it's okay. Then quality will give the go ahead for that. Once the quality gives go ahead, the manufacturer or the supplier person can go for next change. They can go for the next change of ensuring that this particular part is now given at a mass rate to the manufacturer or the OEM. Now this for this all these parts also 1525 trials also, once a part goes to mass manufacturing also, those all traceability are present with the plant, so that if I have again what I've already told you, if I have a part problem in the field, I have the data with me which shows that yes, this particular batch needs to be quarantined, this particular batch of vehicles needs to be checked for any of those problems. And yes, if I get a vehicle with this type of part failing even outside warranty, yes, I will replace it, because this particular part was defined as having problems, or as a part suspected of having problems. PFME needs to be updated even if it's a small change, and maybe if it's a small change, it's just in case the supplier is changing his location, the PFME will not be go for updation as such. But if it's a design change from engineering, which is DFMEA, yes, I will go for PFME change also. With subsequent change to DFMEA, PFME needs to be updated to reflect that particular change. That revision history needs to be updated in PFME also. So this was manufacturing process validation. Now again, this is in-process control validation. Okay, we have 2 more slides, then we can call off this presentation, and then we can go for questions and answer session. In-process control and validation, standardized work, cyclic and non-cyclic quality jobs. Now we have a cyclic operation of doing this particular operation in a particular way. I have that particular quality type of jobs, and I have that particular type of documents reflecting the same. Now, what are non-cyclic quality jobs? These particular jobs are of repair basically. Now, I have something new to repair at my station, or that also. These are non-cyclic. I don't need to follow particular cycle, but I need to follow some steps that need to be followed as it is in a way of manner. And I don't have a time limit in case of non-cyclic quality jobs. But it's not that I'm taking more than an hour for a job that requires me 15 minutes. So even for non-cyclic quality jobs, so that is also defined, and particular critical points in non-cyclic quality jobs are also defined. This non-cyclic quality jobs are a process which go through during the whole duration of a manufacturing cycle of a product, but usually it's of 1 year. Usually it's of 1 year, wherein after 1 year we are in a position that yes, we have almost identified all the non-cyclic quality jobs that go into making of this particular non-cyclic operation or non-cyclic operation for that particular vehicle. Now, the next point is that key process equipment should be identified. That is AC filling, brake filling. This particular equipments are key process equipments because they require a particular amount of in a calibrated manner, the particular amount of brake fluid and AC gas should go inside particular car. If you tell me that what happens when AC is filled, AC is not filled to the uh, specified quantity, and if it's overfilled, what happens is that compressor usually tries to cut off the compressor. What happens is that I try to switch on the AC, but the compressor will try to cut off. It will not ask me help me out in starting the AC, but it will always try to cut off because there is an overfilled quantity of AC inside the system. So this key process equipments are identified as AC filling and brake filling. So I will check the process capabilities of the systems, and now this is why they key process, because these are usually very costly machines, and AC filling and brake filling are on the line, and they are ensuring that line efficiency is maintained while they are filling those things inside the car. Now, if this types of machine fail, I have a backup, but this backup will take time for me because I cannot have two brake filling or two AC filling machines installed at a single line, and one machine is always in idle condition because it's a machine that requires cost. So I cannot have two machines, same type of machines, and one working as a backup and working as a main machine. So what I will do is I will identify the parameters that need to be checked for this machine on day-to-day and on shift-to-shift basis. It's first half, second half. So I will identify those things basis of the report from the supplier, who will tell me that how much after how much cycles that needs to be checked on. So I will be doing that. The maintenance team will have having a PMP schedule again based on the supplier of that machine, who will ask after how many cycles that particular filter needs to be changed, that particular part needs to be changed, a particular pneumatic system needs to be changed. So that will be done on regular basis, and this is proactive approach. We will not be waiting for the system or machine to fail before going for the changeover. And everything, and such as even if this particular system are failing, then corrective actions that are being done and results are being taken needs to be documented in a very clear manner. It should not be that if I'm reading a report, suppose after 1 year, it should not be that I am not able to understand what was being done as a corrective action in this machine. So these things are pre-process equipments, and they need to be taken care in a very documented and very disciplined manner. The next is airproofing device are verified on schedule basis to maintain consistent required functionality. Airproofing device are verified, basically DC tools that we are using for them also. We have identified a system of called as QCOS, Quality Control Operation Sheet, which we will be taking the readings in a manual manner. If I will put a DC tool in any of the car that is running on the line, a process operator will be there. He will be there 4 times during a shift. He will be taking down the data. He will have a graph at that particular station itself. He will plot that graph manually. There will be team leader for that particular station, under whom the operator will be giving the torque to the vehicle. The team leader will also ensure that he takes down the torque 4 times in a shift. Now that particular operator, the first time he came to the station is from quality department, and the first hand quality is again manufacturing. So we are not shipping a defect. So this is a part of moving the defect to next station. So the team leader will be ensuring that his defect is not moving to the next station. So he will be plotting the graph value of the same torque readings that he has taken in the same graph that the quality auditor has audited. So there should not be major difference in the torque readings, and that should be within the upper and lower specification limit of that particular operation. So suppose now, how is this going to help to me? Suppose there is a functionality error in that DC tool which is giving the torque to that wheel nut. What is happening is, if I give a torque to this particular vehicle, and I will come in suppose the second quarter of a particular shift. So at that particular time that 25% to 50% of time that I was not there, if I have a problem in getting the torque, I will tell that 25 the vehicle number this to vehicle number this to the vehicle I'm standing is all suspected. So now I have a small lot to work upon, for which I need to give the torque to each of the vehicles that are being identified, and I can take the subsequent action in a reactive manner. But we have already identified the equipments as pre-process equipments, so that pre-process equipments are being taken care so that these particular things don't happen. And if and when they're happening, we are working on airproofing devices by verification of the same and documenting the audit results. So we have the lot wherein we can take actions when we can confidently say, yes, this particular batch of suppose 50 vehicles are suspected, and we are going to have a talking operation being done on all those vehicles. So this is something which we do as part of in-process control validation. Effective quality checks detection. Again, this is PQS and standardized documents. So this is almost the last slide of our presentation, and it is the quality checks are always defined by risk. What are the risks that are involved for this particular? If a particular checks moves out of my location or moves out of my plant, changes can be temporary. Checks can be added based on results. So this is for quality inspection, that if there is a check and I'm not finding that defect for last 1 year or maybe last 6 months, then yes, I can delete this particular check and I can add some more check. So, but it should be that I have a particular documented backup that says that yes, this particular defect is not coming, and yes, this is not so much important, and we can skip because this has become a part of culture, and this is not going to lose its authenticity in times to come. Inspection verification requirements and audit checks, which we have already taken care. Repair confirmation is also something that is a part of BIQ, because if a repair is done in an improper manner, then it's something that is going to affect the quality of the vehicle. Now, repair confirmation is always independent repair confirmation. It is a quality person who will ensure that the repair that was done on this vehicle is up to the mark, and he has those against PQS that he will go through, and usually he has those PQS in his mind itself, because he's working on, if he's working for more than 2 years or 3 years at a particular line, and he doesn't need PQS with him, and he has gauges, he will take care of those things. He will take care of any noise that has come in the vehicle, and subsequent to repair, any improper repair was done, then he's there to identify those things. Inspection methods: point, touch, and listen. These are those inspection methods that are usually taken in documents, and these things, point, touch, and listen, for this the auditors are calibrated using a benchmark or a master body which we have, and for which also we as an quality managers are accountable for the types of defects that or the skill of that operator that needs to be brought back to or brought up to a certain limit before he can be given to the line for checking of those point, touch, and listen operations. The strengthening of upstream processes. Now, upstream processes are if I'm getting a defect from paint shop to general assembly, or from body to paint shop, this is not acceptable. So those processes needs to be updated, and the things need to be worked upon, so that those particular defects don't move from that particular shop to that particular quality station and subsequently to next shop. So these are something which we usually take into account. Now, MY changes preparation based on lesson learned. So, and what is MY? Model year changes. Model year changes we have usually every year, wherein we go for some improvements in the product, taking into account, yes, this product is not to the mark that is required by the market. Yes, we are going for some change. Maybe sometimes we go for some feature additions or feature deletion which are not required. Always it's more on the side of feature addition, such as the suppose in case of some vehicles in the market, they don't usually have a PEPS type of module with them. What is PEPS module is that keyless entry and engine start. So we usually have the keys wherein we use the keys, put it in the key barrel, and then we start the vehicle. In case of PEPS, it's an antenna based system, wherein the key needs to be there in the pocket of the customer itself, and the vehicle can be started just by sitting inside and having the key inside his pocket. So and the door can be opened, and even the tailgate can be opened with just the key inside his pocket. So these are those changes that usually go into model year changes. Maybe it's addition of LED headlamps which the vehicle had not. The vehicle maybe had projector headlamp type of headlamps. Then you go for new design type of LED headlamps. So these are the things that go into model year changes preparation, and we have some lessons learned throughout that model year. We will use those lessons, and we will take them to next model year, so that the issues that had come in those the earlier model year will not be getting repeated in this model year. So this is always built-in quality thrives on continuous improvement. So if it's a good product, yes, we can improve upon it for surely. So each and every product has its limitation, but yes, it can still be improved from process point of view and from validation point of view. So these are basically the types of boards, types of posters which you use in our day-to-day uses, or even you can find this type of stickers on Google itself. So this is nothing. This is nothing unusual for to see inside a plant, because each and everyone is inside the plant is responsible for his own safety and the quality of the product that he is making. So everyone has the voice, and that needs to be raised if you find something bad. So this is building quality migration strategy. You can see this GMS, which is global manufacturing systems, that is being used by General Motors, and that is the where you have definition of built-in quality. With their built-in quality elements, you can see the built-in quality motto is do not accept, build, or ship a defect. Solve problems to teamwork. So these are the things. These are the methodology which we usually use for our day-to-day work, and for building a culture inside the teams that yes, quality is something for which the customer is paying for. So with this, I'm at the end, almost end of my session. Yes, we can go for now questions for sure. I know there may be many questions, but yes, we will try to cut short as much we can. But yes, we will be questioning. We will be giving answers for each of your questions.
Any participants having the question, kindly they may ask to the speaker. I think Aditya, no question having from participant side.
Okay. Okay. I just hope that you had
Yes,
some
yes,
interesting session, and you have understood at least something, because this is a journey which for me was also taken a long period of time.
yes, yes.
So I've tried to bring it to a small time template as much as I can, but still.
It was such a nice presentation, Aditya, from your side, and it is a really interesting. So I just want to conclude the session,
Yes, sir.
and I having the few remarks that the since last year and year before, a product from the Tata Motors, it was excellent, and day by day the quality which we have seen earlier and today we are seeing from the Tata Motors, it is a completely different. And the reason is like you, Mr. Aditya, you are working with the built-in quality and manufacturing processes, validation quality tools, and processes method, operational control, right? Everything. The success is that what
Yes, sir.
what we have today in product. So
Yes.
thank you so much, Aditya.
Yes, sir. Thank you.
And
It was my pleasure, sir.
yes, I think chat box having the any. Okay, so I conclude the session, Mr. Aditya, that thanks to having with us today, and you have spent your whenever we have required the support from your side, you always be ready and
Yes.
share your knowledge to the students also. We have seen that part also.
Yes, sir.
But today is a special day because of we have arranged the short-term training program as a
Mm-hmm.
beginning of new era, and this is for only for faculty members. And it is a really such a nice day, and it is a pleasure to having with us. Right. So I would like to thank Aditya on behalf of Automobile Engineering Department as well as AD Patel Institute of Technology, our management and CVM.
Yes, sir. Okay. No, sir, it was a good session, and I just hope that every one of here, the faculties that are sitting in this presentation, to find it interesting. And if and when any one of you has a question, yes, you can come through Yagnesh sir also, and you can directly mail me. I will be sharing this mail ID with Yagnesh sir also. You can give me a call, or you can have this question to my mail ID also, and I will be very much happy to help you. And if I going to plan the sessions for your students also, then if and when my support is required in understanding for you or for your students, it will be helpful for me, because ultimately the students that are studying under you are the ones that are going to come into industry in the future.
Yes, yes, definitely.
Yes, sir. So they, though these things should they should be knowing that where they are going and what is expected of them. So it will be helpful to industry and for them also, and for all the institutions that are ultimately working towards setting new benchmarks in education.
Yes, yes, definitely.
Sure, sir.
Okay,
So yes,
Aditya.
thank you.
So,
Yes, sir.
yes, Dhaval.
Yeah. Okay. Good evening, Aditya sir. First of all,
Good evening.
uh, just I want to ask that any software that you use for the line balancing in the Tata Motors?
As such, it's not the software that particularly it's the inbuilt software that Tata Motors is using. It's not that the softwares are being taken from any of the outside manufacturers. It's that each and every OEM has its own system of in Tata Motors we call it as Tata line balancing systems. In GM we have a different methodology, but yes, the softwares that they are being used by these OEMs are for in case of General Motors and Tata Motors I'm talking of. These are their inbuilt systems, and it's not that they are being taken from someone else.
Okay. Thank you.
Okay, anyone else? Okay, I think no more questions have uh, Mr. Aditya.
Yes, sir.
So I am going to conclude the session. Just a minute. Uh, I want to announce the one thing, that tomorrow we having the session at 10 o'clock, and then we will have the session 10 to 12. Then after having the break, and again we will meet on same link at 3 o'clock. Okay, Aditya, fine. Thank you very much.
Thank you, sir.
See you soon.
See you soon. Okay, bye,
Have a
sir.
nice
Bye.
day.
Bye, everyone. Bye.